Hello again. So today we're looking at transforming graphs. All that means is we're looking at how a graph can change. In other words, it can move up, it can move down, it can move left, it can move right, and it can flip about the x or the y axis. So on this first one here, we have a quadratic. We can see that's a function of x squared. On the other one here, we have a cubic. So that's a function of x cubed. If we look at the graph, I've just said y is equal to the function of x, y is equal to f of x. That function in this case looks like it could just be x squared, but it could be 2x squared or 3x squared. I haven't shown what the actual function is. We call this y is equal to the function of x, y is equal to f of x. But this could be anything like y is equal to x squared or x squared, not in this case, but x squared plus 2, or it could be y is equal to 3x squared plus 5 and so on. And again, this one over here could be y is equal to x cubed, or we could change that. We could have it as y is equal to x cubed plus 5, etc. But rather than showing the exact function here, we just call it a function of x. So to transform this, we're talking about moving it. So if I take this graph, I can move it up. So in this case, that could be a function of x, where actually now that one there is y is equal to the f of x plus 1. Or this could be plus 2 or plus 3 or plus 4. It could be that it's moved down here and then the y is equal to the function of x minus 3. On this one over here, it could be y is equal to f of x plus 2 or y is equal to the f of x minus 2. So we can see actually in this case here, on both of these, we could have something like the y is equal to the function of x, the f of x, plus or minus a. So moving up or down gives us this new function where we have this plus a or minus a on the end of it. So in other words, we have a translation through 0a. Okay, so that's something we need to remember. That's one of our rules. So if we have y is equal to the f of x plus a, that's going to translate it through the vector 0a. In other words, 0 across and a up. Or obviously if it's minus a down. Now obviously we're not limited to vertical movements only. It can move left or right. So again, if we look at the function of x, so this can move to the left, maybe it moves to the left 1 or to the left 2 or to the left 3, or it can move to the right 1, 2, 3 and so on. Yeah, the same can occur with this function here. It can move to the left, it can move to the right. So if this moves to the right 2, clearly it can't be plus a in this case because that moves it up and down, so it has to be something different. So in this case what we've actually got here is y is equal to the function, and in the brackets, of x plus or minus a. This is a bit awkward because it's counterintuitive. You would think the plus a would move it to the right, but it doesn't. The plus a moves it to the left and the minus a moves it to the right. So in this case, we translate through minus a, 0. So obviously if that's plus a, it's going in the left direction because that becomes negative a. And obviously if it's a negative, two negatives make a plus, so it goes to the right. So to recap, we've got transformation of a graph here. If it is y is equal to the f in brackets x plus a, we're going to the left. And if it's y is equal to the function in brackets x minus a, we're going to the right. Right, so I'll move these to give ourselves a bit of space. Okay, so now we're looking at this one here. We're going to look at the reflection in the x-axis. So if I take the function y equals the f of x and we reflect that in the x-axis, we would have this. And that is y is equal to the minus function of x. So with the minus outside the bracket here, that is a reflection in the x-axis. Okay, now if we look on this side over here, if we reflect now in the y-axis, so we're reflecting along this line here, so we would get something like this, and that would be y is equal to the function of minus x. So the minus is in the bracket there, and that is a reflection in the y-axis. Okay, let's summarize this. So here we have four axes with the y is equal to the function of x on each one. Now clearly that can be any type of graph. So in each case we have y is equal to the function of x, y is equal to the f of x. So let's write our four rules down here and we're going to have a look at a few. So if we look at the first one and we want to look at the translation from here to here, it goes down 1, 2, 3. So if this function is y is equal to the f of x, then this function here is y is equal to the f of x minus 3. And if we look at this one here and we move it to the right 4, 1, 2, 3, 4, our original function was y is equal to the f of x, and our new translated function is now y is equal to the f in brackets x minus 4. Remember, going to the right is negative, going to the left inside the bracket is positive. So in this one here, we have now got a new function, and that is y is equal to the f of x. So I've changed the starting place from here to here. Now, if we are going to reflect that in the y-axis, we would get this. And now we have got y is equal to the minus f of x. On this last one, we have got y is equal to the function of x. And if it's reflected in the y-axis, we would then get y is equal to the function of the negative x in there. Right, let's bring this together with a couple of questions. Okay, so looking at this one here, we've got two graphs. So we've got y is equal to the f of x here, and we've got an unknown graph here. So we are going to describe the transformation from this graph to this graph here. The first thing hopefully you'll notice is that actually it's flipped, and it's flipped about the x-axis. So we know, going back to our previous rules, we are looking here at a reflection in the x-axis. So we've got the minus f of x happening here. So far we know we have got y is equal to the minus f of x. However, we haven't finished. If that was just it complete, the graph would actually look like that. Now what we have to say to ourselves is, okay, so it's reflected in the x-axis and it's moved left 1, 2, 3, 4, 5, 6 places. So again, going back to our rules, we've translated horizontally, we've moved left 6 places. So what we have here now is we have y is equal to the minus f of x. And if we're going left, it's positive. Remember, right was negative, plus 6. So as you can see, these rules can be combined. Let's look at one more. So we're going from this graph here, y is equal to the f of x, to this graph here. Now, what I didn't say on this one is it's worth picking out a point to translate rather than looking at the whole graph. So when I move this one to the left 6, what I actually did in my head was this. So first of all, I recognized that that graph had flipped, and I chose the turning point here to look at the translation. And as you can see, the distance from this point to this point is going left 1, 2, 3, 4, 5, 6. So that's where that plus 6 came from. So in this case, we can see it has not been reflected in the y-axis and it's not being reflected in the x-axis. So I would suggest what we do is pick a point, and it could just be the top, it could be the bottom, it could be any point on here. I'm going to choose the center point here. And again, if I look closely, there is a point in the center there. So rather than trying to figure out how to translate the whole graph, I translate one point. So I look at this and I say to myself, well, has it gone left and right? Has it gone up and down? Well, obviously it's done both of those. So how much left and right and how much up and down? So in this case, it's gone 1, 2, 3, 4, 5, 6, 7, 8 to the right, and it's gone up 1, 2, 3, 4. So we're looking at a vector here of 8 across and 4 up. So if you were to show that as a translation vector, you would get 8, 4. Let's go back a second. So we're looking at a translation in the x direction, which is this one here. So that goes inside the bracket. So here we go. So we've now got y is equal to the f bracket x. Now we went to the right. Now remember, going to the right is negative a, so it's minus 8. Let's go back a step. So we've done the left and right. Now we're going up and down. So again, we're translating, and if you look at this one here, in the y, it's the plus a after the x in the brackets. So in this case, we have now got plus 4 because it's going up. We've now got plus 4. And that is our new function. What I would suggest is that you learn these so you can recognize if you've got the function of x with a plus a bolted on the end, you're translating up and down. If you've got the plus a within the bracket, you are going left for plus a and right for minus a. If you've got a reflection in the x-axis, it's a minus function of x. And if you've got a reflection in the y-axis, it's the function of minus x. And finally, you need to remember that actually these can be combined. And to combine them, just think of them one step at a time. As always, if you've got something from this, please like and subscribe. And the next video is on the gradient of a curve.